Hello there, and welcome to Cosmic Sleep Stories. Tonight we are drifting into the quiet mystery of intelligence, a subject that sits at the center of every thought we've ever had, every wonder we've felt, every question we've asked about the world and our place in it. Intelligence is not only a human trait. It is a presence that appears in forests, in oceans, in animals with minds unlike our own, and even in the silent patterns that guide the universe. It is the strange ability to imagine, to solve, to adapt, and to create new possibilities from almost nothing. As you settle in tonight, imagine intelligence as a hidden current flowing through everything, shaping life in ways we hardly notice. In some ways it's familiar and comforting. In others it feels so strange that it changes how we see the world. It is one of science's greatest frontiers, and we're only just beginning to uncover its secrets. If you enjoy these quiet journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, all you need to do is rest. Let your eyes relax, allow your body to soften, and let your mind drift gently into wonder. Let's begin. Intelligence may have emerged when early humans began to dream more vividly. In the deep nights of our early ancestors, long before writing or cities, sleep would have wrapped small bands of humans in darkness and vulnerability. Inside those resting bodies, the dreaming mind could roam freely, replaying past events and inventing scenes that had never actually happened. A hunter might relive a close call with a predator, but in the dream, the escape was smoother, the path clearer, the reaction faster. Over many nights, these silent rehearsals could refine instincts without the cost of real danger. Dreams blend faces, places, and emotions into strange new combinations. This creates a mental workshop where the mind experiments with social situations, future threats, and hidden opportunities. The individuals whose dream worlds offered better practice and richer imagination may have navigated the waking world with more foresight and subtlety. Over countless generations, those slight advantages could have helped shape the complex storytelling intelligence that humans carry today. As you rest now, let yourself appreciate the dreaming you do each night. Your mind rehearsing, reorganizing, making sense of the day's experiences in ways your waking consciousness never sees. You are participating in the same process that may have sparked human intelligence itself. The brain can rewrite its own wiring in a single night of intense learning. After a long day spent struggling with a difficult idea or a new skill, the brain does not simply rest. As you sleep, billions of connections quietly reconfigure, strengthening some pathways and weakening others. Neurons that fired together repeatedly during the day are more likely to build stronger links, forming routes that make future thinking smoother and faster. Intricate chemical signals adjust the sensitivity of synapses, the tiny gaps where one cell speaks to another. In deep sleep, the brain replays patterns of activity from waking practice, as if running internal drills without conscious awareness. Even in a single night, this replay can carve new paths through the neural landscape, turning clumsy attempts into more fluent performance by morning. A piece of music feels easier to play. The pattern in data becomes clearer. A foreign phrase sounds more natural. The skull hides a restless city of cells, tirelessly editing yesterday into a better version of tomorrow. And tonight, as you sleep, your brain will do this work for you, reorganizing and strengthening, preparing you for whatever tomorrow brings. Let that be comforting as you drift. You don't need to try. Your brain knows what to do. It's been doing this for as long as humans have existed, this quiet nighttime alchemy that transforms experience into capability. Some animals outsmart humans in tests designed by humans themselves. When scientists create puzzles to measure cleverness, they often expect human minds to sit at the top of the scale. Yet certain animals quietly overturn that assumption. In tasks that require spotting subtle probabilities, pigeons choose the mathematically correct answer more consistently than many human volunteers who are swayed by hunches and stories. In visual memory challenges, some primates can recall the position of many symbols after a fleeting glimpse, far beyond the recall of typical adults. These performances do not simply show quick reflexes. They reveal specialized strengths shaped by different evolutionary pressures, tuned to specific environments and survival needs. While humans excel at language, metaphor, and long-term planning. Other creatures shine in domains where precision, pattern recognition, or sensory detail matter most. The tests themselves, crafted by human hands, become mirrors that reflect our biases about what intelligence should look like. In those reflections, other species sometimes stand taller than we do. As sleep deepens, let yourself appreciate the diversity of minds in the world. Intelligence isn't a single thing measured on a single scale. It's a vast garden of different capabilities, each species brilliant in its own way, each solving the problems that matter to its survival with elegance and efficiency. A tiny portion of the brain predicts your decisions before you become aware of them. Well before you feel that moment of choice, a small network of neurons has already begun to lean toward one outcome. In regions that prepare movements and select actions, electrical activity gradually shifts, favoring one possibility while your conscious mind still feels undecided. This slow build-up of signal, unfolding over fractions of a second, reflects the accumulation of evidence, habits, and subtle preferences stored from many past experiences. By observing these patterns, researchers can often guess which option a person will select slightly before the person reports having made a decision. Conscious awareness then arrives like a narrator who steps onto the stage just after the main plot twist, explaining a choice that was already in motion. This does not remove the meaning of intention or responsibility, but it does suggest that what we call a decision is the visible crest of a much deeper wave of neural activity rolling forward beneath the surface of awareness. Let that mystery settle gently. You are more than your conscious thoughts. Beneath awareness, vast processes unfold, weighing options, preparing responses, guiding you through the world with wisdom accumulated from every experience you've ever had. You can trust those deep processes as you drift toward sleep. Intelligence rises when the brain learns to ignore most of reality. Every moment, the senses deliver far more information than any mind could fully process. Light floods the eyes. Vibrations press into the ears. Countless signals travel from skin, muscles, and internal organs. Intelligent behavior emerges not by absorbing all of this detail, but by discarding most of it. The brain quickly learns which patterns matter and which can fade into the background. It filters out the steady hum of a fan, the constant pressure of clothing, the repetitive shapes in a familiar room. By compressing and simplifying, it frees up precious resources to track changes, unexpected events, and meaningful relationships. The art of ignoring becomes a powerful cognitive tool. Minds that excel at this filtering can build cleaner internal models of the world, models that focus on cause, consequence, and opportunity rather than raw sensation. In that focused inner space, complex reasoning, planning, and creativity can rise above the noise. As you rest now, notice how your awareness is already doing this. You're probably not conscious of the feeling of your clothing against your skin, the subtle sounds in the room, the position of your tongue in your mouth. Your brain has filtered those out so you can focus on these words, on the ideas, on the gentle journey toward sleep. Certain octopuses can solve puzzles they have never seen before. In the dim water of an aquarium or the shifting light of a reef, an octopus encounters a closed container that smells faintly of food. No one has shown it how to open the device. Using flexible arms lined with sensitive suckers, it explores every edge, hinge, and surface. In some species, this exploration turns into remarkably fast problem-solving. The animal discovers how to twist a cap, slide a latch, or pull a plug with movements that reveal more than instinct. Each arm can test different approaches, feeding information back to a nervous system that is distributed rather than centralized. Much of its neural tissue lies outside the main head region, as if parts of its body think locally while still contributing to a shared goal. When the container finally opens, the solution represents a moment where tactile memory, curiosity, and flexible control converge. The result is a display of intelligence that developed along a path entirely separate from the vertebrate mind. Let yourself imagine that distributed intelligence as you drift. Not all thinking happens in one central location. Your body holds wisdom too, in muscle memory, in gut feelings, in the way your hands know how to do things your conscious mind struggles to describe. Intelligence is more diffuse than we usually acknowledge. Your brain generates ideas by mixing signals that were never meant to touch. Inside the skull, networks that evolved for very different purposes constantly interact. A region that once guided hand movements now participates in abstract reasoning about tools. Areas that track space and movement contribute to the way you navigate social situations and numbers. When you relax and let thoughts drift, activity in distant regions begins to synchronize, linking emotional memories with factual knowledge, sensory images with language, and past experiences with imagined futures. Signals spill across boundaries, meeting in association areas that act like busy crossroads. There, unrelated fragments collide in patterns that normally never appear together. From those collisions, new ideas can emerge, like sparks from stones striking at odd angles. A creative insight often feels sudden, but underneath that feeling lies a slow, rich mixing of neural streams that were originally tuned for separate tasks. The mind turns this accidental meeting of signals into deliberate invention. As sleep approaches, your brain is preparing for exactly this kind of mixing. In dreams, the boundaries between different kinds of knowledge become even more fluid. Ideas that seem impossible when awake combine freely, creating strange narratives and surprising connections. Some of your best insights might come from this nighttime mixing. Some trees use chemical messages so sophisticated they resemble primitive thought. In a quiet forest, a single tree detects the bite of an insect on its leaves. Within moments, chemical changes begin, producing bitter compounds that make the foliage less appealing. At the same time, airborne molecules drift outward, carrying information about the attack. Neighboring trees of the same species sense these signals and adjust their own defenses, as if they have received a warning about an invisible danger. Underground, roots form partnerships with fungal networks that transfer nutrients and signaling compounds across long distances. Through these shared pathways, a tree that is struggling can receive resources from others that are thriving, or send out distress cues that alter the behavior of its companions. The timing, specificity, and context-dependent nature of these exchanges create patterns that look strikingly like problem-solving. Without neurons or a central brain, the forest still manages to gather information, spread it, and respond in ways that benefit the community. Intelligence, it seems, doesn't require a brain in the way we usually think of it. It can emerge from networks of communication, from chemical signals passed through soil and air, from communities supporting each other in sophisticated ways. Let that idea be gentle and comforting. You are part of networks too. Family, friends, community. Even when you feel alone, you're connected to others through invisible threads of influence and support. Intelligence isn't just individual. It's collective, shared, woven through relationships. The brain simulates entire futures in the time it takes you to blink. Before you step off a curb, reach for a handhold, or open your mouth to speak, internal models of possible outcomes flash into existence. In brain regions that handle memory and spatial navigation, patterns of activity sweep through imagined paths faster than your body could ever move. The mind rapidly tries out different sequences, predicting where obstacles might appear and how other people might respond. Most of this work happens outside awareness, compressed into moments so brief that they feel instantaneous. When you finally act, the choice carries the imprint of many invisible rehearsals. The same machinery supports more abstract planning, allowing you to picture career changes, relationships, or creative projects unfolding over months or years, all within a brief daydream. By running these compressed futures, the brain lets you harvest some of the benefits of experience without enduring every risk. Each action you take carries echoes of countless unrealized possibilities that lived for only a heartbeat inside your head. And tonight, as you dream, your brain will continue this work, simulating futures, testing possibilities, preparing you for decisions you haven't even encountered yet. Rest in that preparation. Your mind is always working on your behalf, always planning, always imagining, always trying to keep you safe and help you thrive. You can trust it to do this work while you sleep. Human intelligence may depend on neurons that fire in beautifully imperfect patterns. If each neuron responded to inputs in a rigid, repetitive way, your mind would behave like a perfectly wound clock, accurate but predictable. Instead, neural firing is full of subtle variability. Cells sometimes respond strongly to a signal, sometimes weakly, and sometimes not at all, even when the stimulus appears nearly identical. At first glance, this looks like noise, an annoying flaw in a delicate system. Yet this irregularity can enlarge the space of possible responses, allowing the brain to represent shades of meaning rather than simple yes or no categories. Networks of such cells can explore many internal states while still remaining stable enough to function. In this flexible regime, small changes in experience can nudge patterns of activity toward new configurations that encode fresh insights. The mind gains the capacity to generalize, to handle ambiguity, and to combine ideas in unprecedented ways. Intelligence grows not from perfect precision, but from structured imperfection woven through the firing of countless cells. You are not a machine. You are something far more remarkable, a system that thrives on flexibility, on variation, on the creative possibilities that emerge from imperfection. As you drift deeper now, let yourself appreciate your own imperfection, the way your thoughts wander, the way you sometimes forget things or make mistakes. All of that variability is what makes you creative, adaptable, intelligent in ways no perfect machine could ever be. Bees can recognize human faces with a brain smaller than a grain of sand. In a busy garden filled with shifting colors and moving petals, a bee must quickly separate friend from foe, flower from distraction. Despite having a brain smaller than a grain of sand, this tiny creature can learn to distinguish individual human faces with surprising accuracy. It does this not by seeing a face the way humans do, but by breaking the image into a pattern of shapes, edges, and contrasts, then storing the overall configuration as a kind of visual signature. When the same person appears again, the bee can match that signature to its memory and respond accordingly. This ability emerges from an incredibly efficient neural system that uses only a few thousand specialized cells to encode complex images. Instead of processing every detail, the bee focuses on the most informative features, creating a lean and powerful method of recognition. This reveals that intelligence does not depend solely on size. It can arise from elegant design, minimal waste, and the ability to extract meaning from the smallest fragments of perception. Sometimes the most intelligent solutions are the simplest, the most efficient, the ones that do exactly what's needed with minimal resources. Your brain predicts the world before it sees it and calls the mistakes reality. In every waking moment, the brain constructs a silent guess about what will happen next. Before a sound reaches conscious awareness or before a shape becomes fully visible, internal models begin to anticipate the world. These predictions come from memories, expectations, and patterns learned over a lifetime. When the incoming sensory information finally arrives, the brain compares it to its own forecast, blending the two until they match closely enough to feel seamless. Most of the time, this process creates a smooth and efficient experience, letting you move through life without pausing to interpret every flicker of light or shift in sound. Yet the guesses are not always correct. The brain fills in missing details, invents edges that are not really there, and smooths over contradictions that might otherwise feel jarring. This delicate merging of expectation and perception shapes what you believe to be real. Your sense of the world is not a raw recording. It is a refined story built from constant predictions. And as you drift into sleep, those predictions become dreams, stories your brain tells itself about possible worlds, mixing memory and imagination into narratives that feel real while they unfold. Let those dream stories come naturally. Don't try to control them. Just let your brain do what it does, predicting, inventing, creating realities that exist only in your sleeping mind. Dolphins invent new whistles to name ideas they have never encountered. Within the shimmering blue corridors of the ocean, dolphins communicate through whistles that curve and ripple like underwater melodies. These sounds are not simple signals. They have structure, rhythm, and variation that reflect an astonishing level of flexibility. Dolphins can improvise new whistles when faced with new situations, creating custom acoustic shapes that stand for unfamiliar objects, unique individuals, or novel experiences. In social groups, these invented sounds spread as companions learn to interpret them. Each whistle becomes a bridge between thought and expression, allowing the animals to share information with remarkable nuance. The ability to generate symbolic sounds emerges from a brain that evolved for cooperation, hunting coordination, and complex social bonds. Dolphins must understand shifting dynamics within their pods, track relationships, and respond to subtle cues in real time. Their expanding vocal repertoire acts as a cognitive toolkit, allowing them to form new associations whenever the world presents something unexpected. As you rest, appreciate your own ability to create symbols, to use language, to express ideas that have never been expressed before. Every sentence you speak is a small act of creation, combining words in ways that might never have been combined, expressing thoughts unique to your experience. The mind learns faster when it completely misunderstands something first. A paradox lies at the heart of deep learning. When the mind forms an incorrect assumption, it creates tension between expectation and evidence. That tension becomes fuel for rapid improvement. A misunderstanding exposes the boundaries of existing knowledge and forces the brain to reorganize its internal models. Neurons that once fired confidently in one pattern must now shift to accommodate new information. When the correction comes, it produces a sharper, more resilient understanding than if the mind had simply absorbed the idea without friction. This process appears in children who struggle with a concept before mastering it, in adults who confront a mistaken belief, and even in artificial systems that refine their predictions through repeated error. The initial confusion opens a cognitive space where new connections can form more freely. The mind becomes more attentive, more flexible, and more capable of forming insights that would not emerge without the spark of an early mistake. So don't fear being wrong. Don't fear confusion or misunderstanding. They're not obstacles to learning. They're essential parts of it, creating the friction that makes true understanding possible. Ravens can plan several moves ahead without ever practicing the task. High on a windswept branch, a raven eyes a distant reward. To reach it, it must perform a sequence of actions that it has never executed before. Without trial and without guidance, the bird evaluates the objects available and selects the tool that will allow the later steps to succeed. This ability reflects an inner simulation, a process in which the raven mentally rehearses events before acting. Rather than relying on instinct alone, it imagines how each object will behave, how obstacles can be overcome, and how its movements will interact with the environment. Such foresight requires an understanding of causality and physical principles that go far beyond simple learning. It reveals a mind capable of holding multiple possibilities at once, discarding the ones that lead nowhere and choosing the one path that opens a new solution. In this quiet moment of planning, the raven demonstrates a level of reasoning that rivals much larger brains. You have this ability too. The capacity to imagine futures, to mentally rehearse actions before taking them, to plan sequences of events toward a desired goal. It's so natural to you that you probably don't notice how remarkable it is. But tonight, as you drift towards sleep, appreciate this gift of foresight, of imagination, of being able to see possibilities before they exist. Human creativity may come from neural noise that other species filter out. Inside the brain, signals do not flow with perfect order. Mixed within the purposeful firing of neurons is a layer of irregular activity that seems random at first glance. Many species suppress this internal noise to achieve precision and efficiency. Humans, however, appear to preserve a portion of it. This gentle chaos creates opportunities for unlikely connections to form, letting ideas that normally stay separate drift close enough to combine. A stray memory may collide with a sensory impression. A half-formed image may merge with a mathematical concept. These encounters generate new possibilities, often without conscious effort. When attention relaxes, the noise grows louder, allowing the mind to wander through a wider landscape of thoughts. Over time, structured patterns emerge from that wandering, giving rise to metaphors, inventions, stories, and imaginative leaps. Creativity becomes the art of shaping this controlled turbulence into something meaningful. And as you drift into sleep, your brain will embrace this noise fully, letting thoughts combine in ways that would never happen while awake, creating the strange, beautiful, sometimes nonsensical narratives we call dreams. Elephants comfort distressed herd mates with behaviors that resemble empathy. In a savanna shimmering with heat, an elephant senses agitation in a companion. Without hesitation, it approaches with deliberate calm. The touch of a trunk across the face or shoulder carries a soothing pressure. A soft rumble vibrates through the air, a sound tuned to reassurance. Others may gather, offering quiet presence rather than forceful action. These responses arise from an understanding of emotional states within the group. Elephants track the mood of their herd, remembering past events that shaped each relationship. When one individual suffers fear, grief, or uncertainty, the others react with comfort that seems to emerge from shared feeling rather than simple imitation. This emotional intelligence supports the cohesion of their social structure, allowing families to endure hardship and protect vulnerable members. Their comfort behaviors demonstrate that the roots of empathy can grow in minds that evolved far from human experience, carried by memory, sensitivity, and deep relational bonds. You have this capacity too. The ability to sense another's distress and respond with comfort. The ability to offer presence, touch, reassurance. These are forms of intelligence often overlooked but profoundly important. Now, as we drift toward the final moments before sleep, let yourself feel held by all these forms of intelligence we've explored. The dreaming that shaped human minds. The neurons rewiring themselves each night. The animals solving problems in ways that surprise us. The trees communicating through chemical signals. The brain simulating futures faster than thought. You are part of this vast tapestry of intelligence, this universe full of minds and minds not quite minds, all solving problems, all adapting, all creating meaning from the chaos of existence. You belong to this. You are not separate from it. You are one expression of the universe becoming aware of itself. And tonight, as you sleep, your intelligence will continue its work, consolidating memories, strengthening connections, preparing you for tomorrow, dreaming strange dreams that might contain insights you'll only understand later. Your brain doesn't need your conscious participation for any of this. It knows what to do. So let go now. Let your awareness fade. Let sleep come naturally and completely. Trust in the deep intelligence of your own brain, shaped by millions of years of evolution, refined by every experience you've had, perfectly suited to keep you alive and help you thrive. You are intelligent not just when you're solving problems or learning new things, but right now, in this moment of letting go, trusting your brain to do its nighttime work while you rest. This surrender to sleep is itself a form of wisdom. The world is filled with intelligence in forms we're only beginning to understand. And you are one beautiful expression of it, lying here, breathing slowly, drifting peacefully toward the dreams that await you. Sleep well. Dream well. Let your magnificent, imperfect, beautifully noisy brain do what it does best while you rest. But before sleep takes you completely, let's linger a little longer in this space between waking and dreaming, exploring a few more gentle mysteries about the nature of intelligence. Artificial intelligence models reveal patterns in nature that no human had imagined. Modern learning systems can sift through intricate data that spans oceans, climates, and ecosystems. While they do not think in a human sense, their ability to detect patterns creates new windows into the natural world. When given satellite images, they uncover hidden rhythms in the movements of forests, currents, and animal populations. When trained on astronomical measurements, they reveal relationships between distant stars and swirling clouds of dust that had eluded researchers for decades. These discoveries arise not from intuition, but from an unbiased search through vast spaces of possibility. By highlighting connections too subtle or too complex for a human mind to notice, these models expand our understanding of how life and the universe are organized. Their predictions become hypotheses that scientists can explore, grounding imagination in fresh evidence. In this partnership, human insight and computational analysis weave together new stories about nature. Intelligence collaborating with intelligence, each form contributing what it does best. As you rest, appreciate that intelligence comes in many forms. Not just biological, but artificial. Not just individual, but collective. Not just conscious, but also the quiet processing that happens beneath awareness. The universe seems to be exploring every possible way that information can be organized, processed, and used to navigate reality. Parrots can understand abstract rules that even children struggle with. In the presence of colored shapes, objects of different sizes, or patterns arranged in deliberate sequences, Some parrots show an ability to identify rules that are not tied to specific items. They can tell when two things match in a certain property, even when the specific examples change completely. This reveals a grasp of relationships rather than mere memorization. When asked to apply a familiar rule to an entirely new set of objects, these birds can extend their reasoning without hesitation. Their understanding emerges from a combination of social cognition, problem-solving, and a natural curiosity that drives them to manipulate objects and explore cause and effect. These same traits support complex communication and deep bonds with flock members. As they navigate these social landscapes, their minds develop structures capable of handling subtle ideas. What looks simple on the surface reflects a sophisticated internal logic. The ability to understand abstract relationships, to see that two things are similar not in appearance, but in some deeper property. This is one of the hallmarks of advanced intelligence. And it appears in birds, in species whose brains evolved along completely different paths from our own. Let that expand your sense of what minds can do. Intelligence isn't locked into one form, one structure, one evolutionary path. It blooms in countless ways, each suited to the life that carries it. Your brain stores memories by rewriting them in new forms every time you recall them. A memory is not a preserved photograph. Each time you reach for it, the act of retrieval changes its structure. The brain reconstructs the experience from fragments scattered across many regions, stitching sensory impressions, emotional context, and meaning into a single coherent whole. During this reconstruction, the memory becomes open to alteration. New details blend with old ones. Interpretations shift. The narrative takes on the shape of who you are in that moment. Once returned to storage, it carries these subtle revisions. This process allows memories to remain flexible, adapting to new understanding and new circumstances. It also means that the past is partially created by the present. Through this dynamic rewriting, the brain maintains a library that stays relevant to the challenges of life rather than freezing experiences in rigid form. So your memories are not fixed recordings. They're living stories that change each time you visit them, updating themselves to fit your current understanding, your current needs, your current self. The person you are now has access to the same events as the person you were years ago, but the memories themselves have transformed. As you drift deeper, let that be freeing. Your past isn't rigid. Your identity isn't fixed. You're constantly rewriting your story, updating who you were to fit who you're becoming. And tonight, as you sleep, that rewriting continues. Music can restructure thought patterns in ways that increase spatial reasoning. When musical tones rise and fall in carefully arranged sequences, the brain forms patterns of expectation that synchronize activity across regions involved in timing, planning, and prediction. Listening to music can guide neural rhythms into orderly states that encourage more coherent thought. Over time, these rhythmic patterns influence how the brain processes relationships in space, such as rotations, distances, and geometric transformations. Practicing a musical instrument deepens this effect by training fine motor control, auditory discrimination, and working memory simultaneously. As these systems strengthen, they knit together more efficiently, allowing the mind to form clearer mental maps and track complex spatial structures with greater ease. This influence extends beyond the music itself. The structured flow of melody and harmony encourages the brain to explore new connections, supporting reasoning in fields such as mathematics and navigation. Music becomes more than sound. It becomes a quiet architect of cognition. Perhaps this is why music feels so essential to human experience. It's not just entertainment or emotional expression. It's a form of cognitive exercise, a way of training the brain to think in patterns, to predict sequences, to find structure in complexity. Certain plants anticipate light cycles and change their growth before dawn arrives. Long before the sun rises, certain plants begin adjusting their orientation, metabolism, and internal chemistry. These shifts occur even in controlled environments where the timing of external light remains constant. The behavior emerges from internal clocks built into their cells. These track the passage of time through cycles of gene activation and suppression, creating rhythms that align with the turning of the planet. As dawn approaches, plants activate processes that prepare their leaves for photosynthesis. They adjust the opening of tiny pores, redistribute sugars, and alter growth hormones so they can gather energy more efficiently when the first light finally appears. This anticipation helps them survive in environments where every moment of sunlight matters. The precision of these internal rhythms reveals a quiet sophistication. Without nerves or brains, plants still sense patterns that extend far beyond immediate conditions. They carry time within themselves, measuring the turning of the earth, predicting the future based on ancient cycles. You have internal clocks too. Circadian rhythms that know when to make you sleepy, when to wake you, when to release hormones that prepare your body for activity or rest. Right now, those clocks are telling your body it's time for sleep. Listen to them. Trust them. They've been keeping time for as long as life has existed on this planet. Crows understand the concept of zero as a meaningful quantity of nothing. In controlled experiments, crows distinguish between symbols representing different quantities, including the symbol that stands for none at all. They treat this absence of quantity as a real value, placing it correctly on a mental number line. When shown varying amounts of objects, they respond differently to the case where nothing is present, demonstrating an understanding that zero is not simply the absence of something familiar, but a distinct concept with its own place in a sequence. This insight requires a sophisticated mental framework that goes beyond simple counting. It reflects the ability to generalize rules about order and magnitude. In the wild, such reasoning may help them evaluate risk, track resources, or interpret subtle changes in their environment. Their grasp of zero suggests that abstract reasoning can emerge in minds shaped by evolutionary paths far from our own. Understanding nothing as something, absence as a presence. This is a conceptual leap that requires genuine abstraction. Ant colonies act like distributed minds that solve problems no single ant could comprehend. Within a colony, thousands of ants follow simple rules based on pheromone cues, local interactions, and shared tasks. Yet when these individual behaviors combine, the colony displays coordinated strategies that appear far more intelligent than any single ant. They regulate temperature inside their nests by adjusting airflow through complex tunnel systems. They find efficient foraging routes by allowing the most successful paths to gain stronger chemical signals. They defend against invaders using collective maneuvers that shift with the size and position of the threat. This emergent intelligence arises from distributed processing where no leader directs the group. Instead, information flows through continuous movement, chemical exchange, and shared labor. The colony becomes a living network capable of flexible problem solving, adapting to challenges that would overwhelm isolated individuals. You're part of distributed intelligences too. Your workplace, your community, your society, all function as collective minds where individual actions combine to produce outcomes no single person could achieve. Intelligence scales, from neurons to brains to societies to perhaps the entire interconnected web of human civilization. Human intelligence may have strengthened because our ancestors shared stories. In early human groups, storytelling shaped the way individuals understood the world. Around a fire, people described dangers, resources, alliances, and memories. These shared narratives allowed communities to accumulate knowledge that exceeded any one person's experience. Young members learned from the stories of the older ones, gaining insight into events they had never witnessed. Over generations, this cultural transmission created a collective memory that evolved alongside the genetics of the population. Minds that could craft clearer stories, interpret meaning from events, or imagine the experiences of others gained an advantage. Storytelling encouraged empathy, cooperation, and long-term planning, helping early humans coordinate hunts, form alliances, and navigate complex social dynamics. Intelligence became entwined with the ability to weave meaning into the arc of experience. And you carry that legacy. Every time you tell a story about your day, share an experience, explain why something matters, you're participating in the same tradition that may have made humans human. The brain can learn patterns hidden so deeply that you never become conscious of them. During everyday activities, the brain extracts regularities that lie beneath awareness. When exposed to sequences of sounds, images, or movements, neural circuits detect statistical relationships between events over time. These unconscious patterns influence behavior. You may sense the rhythm of a piece of music before recognizing its structure, or anticipate the movement of a crowd without knowing why. This implicit learning shapes skills such as language, coordination, and social intuition. It allows the mind to adapt to environments too complex to analyze consciously. The process operates continuously, building internal models from countless tiny correlations. These models guide perception and action, even when the details remain hidden from conscious thought. The brain becomes a silent analyst, discovering structure in the world without deliberate effort. And tonight, as you sleep, this unconscious learning continues. Your brain processing patterns from the day, extracting meaning, building models, all without your awareness. Human problem solving improves when the mind begins to wander. When focus softens and attention slips away from a stubborn problem, the mind does not truly switch off. Activity shifts into networks that connect distant memories, half-formed impressions, and forgotten details. This roaming state lets ideas move into new combinations that strict concentration often blocks. A passing smell can link to a scene from childhood. A sound can pull up a lesson learned long ago. While you fold laundry, walk a familiar path, or stare at the ceiling in the dark, the brain continues to reshuffle patterns beneath awareness. Possibilities that were previously invisible slide into view. An approach that felt impossible a moment earlier suddenly seems natural. This effect appears in artists, scientists, and anyone facing tangled choices. Wandering thought becomes a quiet workshop where new structures of understanding are built without effort. What looks like distraction from the outside becomes, on the inside, a deep reorganization of how a problem is framed. So as you drift now, let your mind wander freely. Don't try to hold on to any particular thought. Let ideas float by like clouds. Some will connect in unexpected ways. Others will dissolve. All of it is your brain doing what it does best, exploring possibility space, making connections, preparing insights that might emerge tomorrow or next week. Infants show signs of statistical reasoning before they understand words. Even in the first months of life, human babies track regularities in their surroundings with surprising precision. When they watch shapes appear in patterns or hear streams of syllables, their gaze and attention reveal that they sense which combinations are common and which are rare. Experiments show that when an event violates these emerging expectations, their eyes linger slightly longer, as if something in the scene does not quite fit the forming model in their minds. They have no vocabulary, no formal training, and no explicit grasp of numbers. Yet their brains quietly tally how often certain sounds follow others, how frequently lines move in particular directions, and how objects tend to interact. This sensitivity helps them separate meaningful units in language, recognize familiar arrangements in the world, and learn where to focus curiosity. Long before a child can describe a pattern, the nervous system is already measuring it, laying foundations for later reasoning with a patient and continuous internal count. You were doing this once, as an infant, learning the statistical structure of language and the world before you had words for any of it. That capacity for implicit learning never leaves you. Your brain is still tracking patterns, still measuring probabilities, still learning from the structure of experience even when you're not consciously trying to learn anything. The brain compresses vast amounts of information into tiny neural sparks. Every moment, light, sound, smell, touch, and internal sensation arrive in sprawling detail. If the mind tried to store all of this in full resolution, thought would freeze under its own weight. Instead, chains of neurons transform the flood into compact codes. Groups of cells fire together in patterns that summarize edges, movements, textures, and meanings. Many details vanish, but the important relations remain. A familiar face reduces to a particular constellation of activity. A remembered route becomes a sequence of compressed steps that can later unfold into a clear mental journey. This compression is not simple shrinking. It is clever selection, preserving information that supports prediction and action while discarding background noise. When you recall an event, a relatively small spark of activity in key regions can reconstruct sounds, feelings, and images with surprising richness. Intelligence depends on this ability to pack experience into efficient symbols so that the mind can move quickly through thought instead of drowning in raw sensation. Your brain is constantly compressing, constantly finding the essence of experiences and storing that rather than every detail. This is why memories feel vivid but aren't perfect replicas. You remember the meaning more than the specifics. And that's exactly what you need. Human foresight emerges from brain areas that first evolved for social behavior. Regions that now help you picture next week, next year, or the distant future began as tools for tracking other minds. Early humans needed to remember who helped and who harmed, to anticipate how companions might react, and to imagine the consequences of sharing food or withholding it. These demands strengthened circuits that could build inner scenes of events that had not yet happened. Over generations, those circuits expanded their reach beyond immediate social exchanges. The same networks used to imagine a friend's response could now model the outcome of a journey, a new dwelling, or a change in hunting ground. As language grew more complex, these imagined scenes became easier to describe and share, allowing groups to coordinate around futures that existed only in thought. Planning cities, technologies, and cultures draws on neural machinery that once served small bands of foragers, revealing that our sense of tomorrow is deeply rooted in the ancient need to navigate relationships. You use this machinery every day, imagining how others will react, planning conversations before they happen, anticipating outcomes. Social intelligence and future planning are intertwined because they both require imagining scenarios that don't yet exist. Your mind predicts other minds by simulating them using pieces of itself. When you watch someone frown, hesitate, or light up with excitement, your own neural circuits quietly echo those expressions. Brain regions involved in your feelings and actions activate, as if you were experiencing a softened version of what you observe. Using these echoes, the mind assembles an internal portrait of another person's perspective. It borrows its own patterns, then reshapes them to fit the hints it can see. Experience refines this process. Every conversation, conflict, and moment of connection adds detail to the internal models you carry. Over time, you learn to sense when someone is confused, guarded, honest, or hiding distress, even without explicit signals. This capacity to simulate others supports trust, cooperation, teaching, and the subtle dance of everyday interaction. It is a form of intelligence that depends on using the self as raw material for understanding those who stand outside the self. You understand others by temporarily becoming them in your imagination, feeling what they might feel, thinking what they might think. Human intelligence thrives when diverse ideas interact inside a single mind. Creativity and insight flourish when the mind holds many different kinds of knowledge at once. When ideas from unrelated fields collide, they generate combinations that would never arise from a single discipline. A person who understands art and mathematics may discover patterns invisible to someone focused on only one. Someone familiar with both storytelling and engineering may find solutions that blend imagination with structure. Within the mind, these different domains mingle, compare, merge, and reshape one another. This interaction strengthens cognitive flexibility, broadens perspective, and encourages novel thinking. Diversity of thought becomes a catalyst for innovation because it allows the mind to draw connections across distant regions of understanding. The more varied your internal landscape, the more paths exist for intelligence to travel. So keep learning different things. Keep exposing yourself to ideas from different fields. Let your mind become a crossroads where diverse knowledge meets and creates something new. As we drift toward final sleep, let all these ideas about intelligence blend together in your mind. The neurons firing in imperfect patterns, the memories rewriting themselves, the unconscious learning, the wandering thoughts that solve problems, the social intelligence that predicts other minds, the compression of vast experience into efficient symbols. All of this is happening in you, right now, as you rest. Your brain is not a static object. It's a dynamic process, constantly changing, constantly adapting, constantly becoming something slightly different than it was a moment ago. And this process continues whether you're aware of it or not. In fact, some of the most important work happens when you're not paying attention, when you're resting, when you're sleeping. So trust this process. Trust your brain to do what it needs to do. Trust the deep intelligence that's been shaped by millions of years of evolution and refined by every experience you've had. You don't need to understand how it all works. You don't need to consciously direct any of it. You just need to rest, to let go, to allow your brain to enter the states it needs for consolidation, for reorganization, for the nighttime alchemy that transforms today's experiences into tomorrow's capabilities. Intelligence is a mystery. Consciousness is a mystery. How neurons create thoughts, how matter becomes mind, how the electrochemical activity in your skull generates the vivid experience of being you. All of these remain fundamentally mysterious despite all we've learned. But you don't need to solve these mysteries to benefit from them. You are intelligence. You are consciousness. You are the universe experiencing itself through this particular arrangement of atoms at this particular moment in time. And now it's time to let that experiencing rest, to enter the different mode of consciousness we call sleep, where the rules change, where impossible things feel natural, where your brain does its deepest work beneath the surface of awareness. Let go now completely. Release any remaining tension. Allow sleep to arrive in its own time, natural and inevitable as the turning of the earth. Your intelligence will be there when you wake, refreshed and reorganized, ready for whatever tomorrow brings. Trust that. Rest in that. But let's linger just a moment longer in this peaceful space, exploring a few final thoughts about the vast landscape of intelligence that surrounds and includes you. Whales communicate through layered signals that function like multi-level languages. In the open sea, whale vocalizations travel across vast distances. These sounds contain multiple layers of structure, including repeating units, shifting patterns, and long sequences that can last for minutes or even hours. Some species combine basic elements into larger motifs, which then form extended songs that vary by region and social group. Individuals modify their calls in response to companions, adjusting timing, pitch, and rhythm. This layered communication system allows whales to coordinate movement, maintain contact, and convey information about identity and emotion. The complexity resembles early forms of language because the meaning is not tied to a single sound, but emerges from patterns arranged across time. Each population develops unique variations, creating dialects that shift gradually through generations. Their voices become both a practical tool and a cultural expression, songs passed from parent to child, evolving slowly like the songs humans sing, carrying information across the vastness of the ocean. Imagine those whale songs now as you drift, complex melodies traveling through dark water, connecting individuals separated by miles, creating a sonic web of relationship and meaning. Intelligence expressing itself through sound, through pattern, through the patient elaboration of musical structure. Termite mounds behave like climate-regulating machines built by collective intelligence. Under intense sun and heavy rain, towering earthen structures rise from the ground, constructed grain by thousands of tiny workers. Inside these mounds, air flows through a network of passages that channel heat and moisture in intricate patterns. Each insect follows simple rules. It carries soil to locations that feel too warm or too damp, removes material where air seems stagnant, and responds to subtle changes in scent and temperature. From these countless small actions, a ventilation system appears that keeps the inner chambers close to ideal conditions for the growing colony. The mound adjusts over time as seasons shift, with new channels opening and old ones closing. No architect holds the plan in its mind. The structure emerges from constant feedback between insects and environment. In effect, the mound behaves like a self-tuning device that measures and balances the climate using nothing more than instinctive behavior woven together at immense scale. No single termite understands the mound, but the colony as a whole solves problems of climate control that would challenge human engineers. Intelligence emerging from simplicity, from the interaction of simple rules followed by many individuals. You're part of similar systems. Your body is a colony of trillions of cells, each following relatively simple rules, yet together creating the miracle of consciousness. Your society is a colony of billions of humans, each making individual choices, yet together creating culture, technology, civilization. Coral reefs exhibit collective responses that mirror decision-making in living networks. Beneath warm waves, reefs form intricate frameworks of stone and living tissue. Each coral polyp feeds, grows, and reproduces according to local conditions. Yet the community as a whole behaves like a single adaptive entity. When water temperature rises or light levels change, chemical signals spread through the reef, prompting shifts in how polyps share nutrients with their symbiotic algae. Some sections may reduce growth to conserve energy, while others ramp up repair to counter damage. These adjustments are not directed by a central leader. They emerge from the sum of local interactions, as each organism responds to both its immediate environment and the altered state of its neighbors. The result is a distributed response that can hold a complex system together in the face of stress. In this way, the reef performs something very similar to collective decision-making, selecting beneficial strategies through countless small acts of physiological negotiation. The intelligence isn't in any individual polyp, but in the network of their interactions. Let that image soothe you as sleep approaches. You don't have to figure everything out alone. You're part of networks, families, communities, humanity itself. Intelligence is often distributed, shared, emerging from connection rather than isolation. Slime molds solve mazes through a form of memory stored in their shifting shape. Despite lacking neurons, slime molds navigate complex environments with surprising intelligence. When placed in a maze with a food source positioned at the exit, the organism spreads through every available path. Over time, it withdraws from dead ends and reinforces the route that leads to nourishment. This process resembles memory, not stored in cells, but in the changing geometry of the organism itself. Each stretch and retreat leaves a subtle chemical traces that influence future movement. As the slime mold reshapes its body, its shifting form records which paths are useful and which are not. The result is a dynamic map etched into living tissue. Through continuous growth and retraction, the organism learns and remembers without a brain, revealing that intelligence can arise from the simplest materials when organized in the right way. Intelligence doesn't require complexity. Sometimes the simplest systems, following basic rules, can exhibit behaviors that look remarkably intelligent. The universe seems to have discovered countless ways to process information, to learn, to adapt, to solve problems. Birds with tiny brains can perform logic tasks once thought impossible without a cortex. Despite their small size, the brains of certain birds contain densely packed neurons arranged in highly efficient networks. These structures allow them to reason about relationships, understand cause and effect, and perform tasks that mirror logical decision-making. Experiments show that some birds can identify whether items match certain rules, choose correct options from multiple alternatives, and even understand basic relational concepts. Their success does not come from mimicry alone. It emerges from internal processes that track patterns, test hypotheses, and evaluate outcomes. These birds solve problems using strategies that reflect structured reasoning. Even though their brains lack the layered cortex seen in mammals, this discovery challenges long-held assumptions about how intelligence is built. It shows that thinking does not depend on size, but on organization, density, and the way networks connect. In the flutter of wings and the tilt of a small head, powerful cognition reveals itself. Intelligence finding ways to exist in the smallest of packages, efficient and elegant. The mind identifies patterns by creating stories even when none exist. When confronted with scattered details, the mind instinctively forms connections, turning fragments into coherent shapes and meanings. This tendency emerges from ancient survival needs. Early humans benefited from sensing structure in the environment even when the structure was faint. Over time, the brain became specialized for weaving elements into narratives that explain what might be happening. This can lead to false impressions, but it also fuels creativity, imagination, and interpretation. When people see shapes in clouds, find rhythm in random sounds, or draw meaning from coincidences, they are witnessing this narrative instinct at work. It helps the mind compress complexity into forms that feel understandable. It provides emotional coherence and guides decision-making. Although it can mislead, it also drives curiosity and exploration. The mind makes sense of the unknown by shaping it into a story that feels whole. And tonight, your mind will tell itself stories and dreams, creating narratives from the random firing of neurons, making patterns from chaos, because that's what minds do. Human curiosity expands when the brain encounters something it cannot predict. When the mind meets a situation that does not match expectation, a spark of heightened attention ignites. neural circuits become more active, absorbing detail with greater sensitivity. This surge of interest encourages exploration, allowing unfamiliar information to flow into memory more deeply than routine events. Curiosity grows in this gap between what is known and what feels just out of reach. It pushes the mind to investigate, compare, experiment, and reorganize understanding. These moments often shape lifelong interests, guiding people toward fields of study or creative passions they might never have pursued otherwise. The brain thrives on novelty because it expands the range of possible ideas, revealing new paths through the world. Curiosity becomes both a compass and a fuel, pulling the mind forward whenever the horizon shifts. Even now, as you drift toward sleep, your curiosity persists. The curiosity that brought you here tonight, listening to these ideas about intelligence. That curiosity is itself a form of intelligence, the drive to understand, to wonder, to explore. Honor that in yourself. The brain builds maps of the world using rhythm, like an internal song. Deep within the brain, networks pulse with repeating patterns that act like a silent melody, guiding perception and movement. These rhythmic cycles help organize spatial information, allowing the mind to track locations, distances, and boundaries. As you walk through a room or move along a familiar road, these internal rhythms synchronize with sensory input, creating a stable map that persists even when vision is limited. They provide a scaffold for memory, helping you recall where objects lie, which paths you have taken, and how far you have traveled. These internal songs shift subtly as you change pace, direction, or goal, adjusting the mental representation of space. Without these continuous pulses, navigation would become disordered and unstable. The rhythm gives the world structure inside the mind. Right now, those rhythms are slowing as you prepare for sleep. The internal songs becoming quieter, gentler, as your brain shifts from the active rhythms of waking to the slower oscillations of sleep. Let those rhythms carry you, like a lullaby sung by your own neural networks. Human language may have emerged when our ancestors learned to manipulate symbols for fun. Before words carried meaning, early humans likely experimented with sounds, gestures, and marks simply because they found joy in play. These playful acts created patterns that companions began to recognize and repeat. Over time, certain sounds gained consistent associations with common objects or actions. As these associations solidified, groups developed shared symbolic systems rooted in joy, curiosity, and creative exploration. Play allowed individuals to test new forms of expression without fear of error. It encouraged imitation, variation, and elaboration. Gradually, these simple symbolic experiments grew into richer forms of communication. From casual mimicry emerged structure. From shared pleasure emerged understanding. Language may have begun as a form of imaginative play long before it became the tool that carries thought across generations. The most sophisticated human capability might have originated in something as simple as play, as joy, as the pleasure of making sounds together. And you still play with language. Every joke, every pun, every creative use of words is play. Intelligence at play, enjoying its own capabilities, creating meaning and beauty from arbitrary symbols. Your brain understands motion before it recognizes the objects that are moving. As soon as something shifts in the environment, specialized pathways in the visual system react to the change even before the brain identifies what is moving. This rapid sensitivity to motion comes from ancient neural circuits that evolved to detect predators, prey, and other crucial events. These circuits respond to direction and speed with astonishing quickness, allowing the mind to prepare for action before conscious recognition forms. Only after this first wave of activity does the brain piece together shape, texture, color, and identity. This separation gives humans a powerful advantage. Motion sets the stage, drawing attention to areas that matter, guiding gaze and sharpening perception. This early processing influences decisions, emotions, and expectations, shaping how a person responds to the world. The deep layers of the visual system reveal that understanding movement is not a refinement of sight, but one of its earliest and most fundamental purposes. Your brain prioritizes what changes, what moves, because change is what matters for survival. Human insight often appears when the brain switches into a metastable neural state. Inside the brain, countless networks hum with their own rhythms. When an insight emerges, the system briefly enters a fluid condition where these rhythms loosen, reorganize, and reconnect in unusual ways. This state lies between order and chaos. It is not fully stable, yet not disorderly. During this delicate moment, information that was stored in separate regions can suddenly interact, creating new relationships that the mind had not considered before. People often experience these moments as sudden clarity. A problem that felt impossible becomes simple. A connection that once seemed hidden becomes obvious. This shift does not result from direct effort. It comes from the brain allowing itself to move into a flexible arrangement where ideas can reorganize freely. Once the insight forms, the system settles again, holding the new understanding in a more stable pattern. Insight arises from the brain's ability to briefly relax its normal boundaries and explore new internal configurations. Tonight, as you sleep, your brain might enter these states naturally, reorganizing knowledge, creating new connections, preparing insights that will feel sudden when they arrive tomorrow or next week. Trust that process. Human intelligence may be expanding as we integrate with the machines we create. As technology becomes woven into daily life, human cognition evolves alongside it. People extend memory through digital storage, amplify pattern recognition through analytical tools, and explore ideas with computational assistance. These machines do not replace thought. They expand its reach, transforming how humans learn, create, and understand the world. Interacting with technology encourages new forms of problem-solving that blend biological intuition with artificial precision. It also reshapes communication, collaboration, and the pace at which knowledge grows. Over time, this partnership between human and machine forms a hybrid intelligence capable of insights neither could achieve alone. The merging is not physical but cognitive, built through constant exchange between organic minds and the tools they design. As this integration deepens, human intelligence stretches into new territories, reflecting an ever-expanding interplay between creativity and invention. You are living through a remarkable moment in the history of intelligence. The merging of biological and artificial, the amplification of human capability through technology, the creation of new forms of hybrid thinking. Whatever this leads to, you're part of it. Now, finally, as we reach the end of this journey through intelligence in all its forms, let yourself feel the completeness of this exploration. We've traveled from dreams to neurons, from octopuses to elephants, from ant colonies to artificial minds, from ancient evolutionary roots to the present moment of technology and hybrid intelligence. All of this exists. All of these forms of intelligence are real, operating right now across the planet and in the machines we've created. And you are one expression of this vast phenomenon. Consciousness arising from matter, awareness emerging from complexity, thought flowing from the organized activity of cells. You don't need to understand it all. You don't need to hold on to any of it. You just need to rest now, knowing that intelligence in countless forms continues its work whether you're awake or asleep, whether you're paying attention or drifting in dreams. Your own intelligence will be there tomorrow, refreshed by sleep, reorganized by dreams, ready to engage with the world in whatever ways feel right. Trust that completely. Let go of everything now. Every thought, every question, every wonder. Let it all drift away like clouds dissolving in a clear sky. You are safe. You are held. You are part of the vast web of intelligence that includes every thinking thing on Earth and beyond. Sleep comes naturally when you stop trying, when you surrender to the rhythms your body knows, when you trust the processes that have kept humans alive for hundreds of thousands of years. Your brain knows what to do. It has done this every night of your life. It will continue long after you stop consciously directing it. So stop now. Let go. Surrender to sleep. The mystery of intelligence remains, but you don't need to solve it tonight. You just need to rest in it, to be it, to allow your own intelligence to do what it does best while you sleep. Good night.